What we're doing today is the opposite, backwards of what we've been doing now for a few lessons. Okay. For a few lessons, we give you a polynomial, we give you possible solutions, or you find possible solutions, right? And then we did synthetic division so that we could get the depressed polynomial, right? And then we factored it all so that we could find the actual solutions, right, to the polynomial. Today, we're going to go backwards. We're going to give you solutions. We're going to say, hey, the solutions to this polynomial, we don't know what the polynomial is, the solutions to this polynomial are -1, 2, +3. And then we're going to work backwards. And we're going to end up with a polynomial. Okay? So we're going to start with this. The difference between a factor in terms of like polynomials and factoring polynomials, when we think about that, what's the difference between a factor and a solution? Okay? Take 10 seconds, talk to somebody next to you about that. The factor of a polynomial. Like when we go to factor out a polynomial, what's that look like usually? Like one of them. X plus 3, cool. Right? What would the solution to that be? X equals -3, right? Okay. Well, the reason that we can get this solution is because this factor is set equal to what? Set equal to 0, right? Okay, so now here's my challenge to you. What if we didn't have this? And I only told you this. X equals -3. Could you tell me what the factor is? Yeah, we just do +3, +3. And we would get x plus 3. What if it was a negative version? What if we had, x equals, let's say 2. What would we do? Right, so it'd be x minus 2. Right? That's a really foundational thing with what we're doing today. So if you have a question about that, ask it now. We good? All right. So here's an example. And I want you to just write the factors for this one, and then we'll go from there. So I'm telling you that the solutions, the zeros, the x-intercepts for the polynomial are -2 and 4. I want you to write the factors of that. So you're going to have your parentheses like this. What's going to go in there if the solutions are -2 and +4? What's going to go on the first one, Zayden? X plus 2. Okay, what's going to go on the second one, Carson? X minus 4. Okay. Now, again, we're working backwards, right? So now how would I turn this into a polynomial? We have to FOIL. X times x, x squared, x times -4, -4x. 2 times x is positive 2x. 2 times -4 is -8. Then we combine like terms. X squared minus 2x minus 8. Any questions on that one? This is the most basic that we're going to do. Okay, we're going to take steps from here. I wanted to start with this one. Okay, now we're going to pull it off of a graph. So if I zoom in on this, what are the solutions of this graph? Yeah, the x-intercepts. So -2, +1, and 4. So the first thing I would do is go up here and say x equals -2, +1, and 4. So now we're going to write our factors, but this time we're going to have 3. What degree is this polynomial going to be? To the 3rd degree, right? Because we have 3 solutions. So that's just something that you can keep in the back of your mind. So now write your factors. You're going to have 3 of them now. Here, what do you got for the first one? X plus 2. Okay, Joy, what do you got for the second one? X minus 1. Good. Daniela, what do you got for the last one? Good. Okay, now we have 3 binomials that we're multiplying. Can we do all 3 of them at the same time? No. Okay, can't. We have to do 2 at a time. With this one, it's not really going to matter. But on the next two, we're going to be like strategic about which two we do first. Okay, this one, it doesn't matter. So let's just do the first two. So I want you guys to FOIL these two right here. First one is going to be x squared, right? X squared minus x plus 2x minus 2, yeah? Then we combine like terms, x squared plus x minus 2. You guys agree with that? Now what do I do with that x minus 4, my other factor? Do I just forget about it and ignore it, and am I done? How do I know I'm not done? Is my degree correct? No, my degree's not right. It's x squared, and I need to be to the third degree. So I have to bring this x minus 4 down here. Oops. And now we FOIL again. And we're going to have x cubed minus 4x squared plus x squared minus 4x minus 2x plus 8. Do I have 6 terms? Yep. Now we combine like terms. X cubed, and then I can combine my x squared, so it's going to be minus 3x squared minus 6x plus 8. And that is our answer, our polynomial. Okay, now read this. That makes sense to you? I see a lot of faces like this. Like a lot of faces like scrunched up eyebrows and sideways looks. Okay, here's what this means. Okay, it means that our imaginary solutions travel in pairs. Okay, that's kind of the summarized version. So if I tell you x equals negative 3i is one of our solutions, then what has to be the other one? Has to be the positive version of it too. If I tell you that it's x equals 2i, that means I have to have what? Have to have the negative version of it. Yes, you always will have the plus or minus of it. Always. If it's imaginary. The same is true, this is this bottom note here, the same is true for square roots. So if I tell you that x equals the square root of 5, it also equals negative 5. Because when we use square root to solve for something, we always do plus minus. So we have to have both versions, the positive version and the negative version. Okay? So then using this, we can create additional solutions that may be missing, and then we can factor it, even if we're provided with one imaginary solution. So let's take a look at this one. First of all, we've got something missing over here. What should go in that box? X is 3, x is positive 3i, negative 3i. Right? Because we know that if the positive version of 3i is a solution, then the negative version also has to be, because it always travels in plus minus in pairs. So now our factors are going to be x minus 3, x minus 3i, x plus 3i. Now this is where I said we're going to be very strategic with which ones we do first, okay? And I'll be fully transparent. I did not do this right the first time I did it, first period, and we ended up with a whole page of a whole bunch of work. We got the right answer, but it was like 5 times more work than what we needed to do. Okay, so here's what you have to do. You have to use your eyeballs. You have to be observant. You have to notice that these two are conjugates. Remember, a conjugate is when you have the same thing, but just different signs, opposite signs. So it's x minus 3i and then x plus 3i. They're conjugates. Remember, we used this when we had imaginary numbers in the denominator, right? We used conjugates to eliminate the imaginary numbers from the denominator. So we want to start with this because it's going to give us our most simple thing to factor with here, okay? Or to FOIL with. So let's do that. X times x gives me x squared. X times 3i is going to give me positive 3ix. Then we do negative 3i times x, so that's negative 3ix. And then negative 3 times negative 3i times positive 3i is going to be negative 9i squared. Here's why this is helpful. We are going to be able to eliminate from this all of our imaginary numbers. Because my 3ix and negative 3ix are going to cancel out, right? So I have x squared. And then that negative 9i is going to turn into positive 9 because I squared is negative 1. Negative 9 times negative 1 is positive 9. Now I just bring my x minus 3 down. And now we FOIL this new set. Go ahead and do that. Is that going to be my final answer? It's not wrong, but it's not all the way right. What would I need to do? Write it in standard form, which means we write it in the correct order. So x cubed minus 3x squared plus 9x minus 27. Any questions on that one? Okay. Now we have an irrational as a solution. Square root of 7. That's the positive version, right? So what else do we have to include over here? Yep, we have to have the negative square root of 7 as well. We're going to do the same thing we did on the last one, except instead of using I now, we just have the radical. So go ahead and set up your factors. Which two should I FOIL first? Yes, do the radicals first, because again, we have the conjugates, right? So we're going to be able to cancel stuff out on that one more easily. So it's going to give me x squared plus x square root of 7 minus x square root of 7. And then minus, how do I multiply radicals? What do I do? What's 7 times 7? Yeah. When you multiply radicals, you just multiply what's called the radicand, which is the number inside, right? As long as they have the same index, which they do. They're both square root here. Which then, yes, we can simplify that further. The square root of 49 is 7. And we can combine. These are going to cancel. So I end up with x squared minus 7. And then I still have my x plus 2 over here. And then we finish foiling. Make sure you write your final in standard form. Yes. Okay. All right. Your homework is a worksheet. Okay, we're going to skip number 8.